Today we're going to talk about the empirical rule, standard deviations, and then normal distribution. So what you're looking at here is the normal bell curve. You've probably heard that as well. The normal distribution, normal bell curve. We're going to talk about what all these values mean, and we're going to talk about what the parts of the graph mean. First thing I want you to notice on this bell curve is that it is symmetric on both sides, and notice as well the center of our thing is the mean, it is the average. If you look to the right, it says the mean plus 1s. That's one standard deviation. That lowercase s stands for population standard deviation, or sample standard deviation. We'll talk about what a standard deviation is as well. The second line is 2 standard deviations above, and the third one is 3 standard deviations above. And then below we have the mean minus a standard deviation, 2 standard deviations, and then 3. So we're always going to be centered on our average right there. So we need to first find the average, and then we can find our standard deviation. There's a formula for standard deviation, but we won't have to worry about that. We'll be given those values. So here's what the normal bell curve is. What the normal bell curve tells us is between the first deviation, which you can see from here to here, 68% of all data should fall into this region. That is 1 standard deviation above and below. And you can see your marking there with the arrows. 68% of the data will fall in here. The next thing we see, the second standard deviation. That would include not only these regions that we see to the edge here, but also the deviation that we talked about at the front. That includes the 68% in the middle. So 95% of our data will fall into this region that I'm highlighting here. And again, you can see the markings from our arrows here. 95% of our data falls in that region. And then the last one is the third deviation. See, our third deviation, again, is not just these 2 little pieces of pie right here. It is the entire bell curve, which we had before. So 99.7% of our data will fall into this range. And this is called the empirical rule. We don't force things to fit in this. If something has a normal distribution, this is what it looks like. So 99.7% of our data will fall into this region. So that's what we have when we're talking about the normal bell curve. We'll keep this to the side, and you can also see I've got a little marker here. Might be wise to write these down as we go along. But you can see that the 68%, which is the first deviation, is broken down into 34% below and 34% above, because you add those together and we are back to 68%. Between the first and second standard deviation, you can see we have 13% above and below each, for a total of 27%. And then between the second and third deviation, first and second deviation is 2.35%, and then of course the last little bit is 0.15%. So here's how we construct a normal bell curve on our empirical rule. As I said at the beginning, we need to first start with the mean. So as we read our instructions in here, suppose the score of a test is normally distributed, and the mean of the test was 80. Well, whatever the mean is goes in the center. So we have a mean of 80, and then we next need to know what is our standard deviation. Our standard deviation, what that is telling us, a deviation means to move away from. So a standard deviation is just a normal movement. So a standard deviation above would be 7 more than the mean, which in this case would be 87. And then 7 below the mean would be 80 minus 7, would take us down to 73. So what our normal distribution tells us is that between the scores 73 and 87, 68% of our scores should fall in that range. Then to find the next deviation, we just add another 7. So to go from 87, we go plus 7 again. This will take us to 94. That is the second standard deviation above. And then we would go minus 7 from the score right here, which takes us down to 66. And again, just like our bell curve tells us, this little region here is going to be about 13.5% of our information. 13.5% will fall here as well. And we'll go ahead and divide this up as well. We'll stick to our 34 on each side of the mean. So 34% will fall here, 34% will fall here. And then the third deviation, anything beyond a third deviation we consider an outlier. So when we add 7 to this score, this would be 101. If we subtract 7 from this score, we would be down to 59. Anything above these two numbers is going to be considered an outlier. What an outlier is a number that is not representative of the data collected. This happens for a number of reasons. We're not going to get into all of those, but we consider them outliers if they are misrepresentation of the data. All right, so let's take a look at this. What percentage scored less than 87 on the test? So if we're looking at 87, 87 is our second deviation. We can do a number of things. As we look at our chart here, we can start to tally up the points that we have moving this way. So as I go this direction, I tally up the percentage points that go with this. There's another way we can look at this. We can look back at our bell curve and see that, hey, this is the second deviation, the third deviation up to the first, and then we just add our percentages up to this point. We can add our 68, which is clear to see. We have 68% falling in there, so we have 68% coming from here to here. We take another step, and that will add another 13.5%. We take another step, and if we look at our table right here, this is going to be 2.35%. So we add 2.35%. And then the last, and that's our deviation below the third deviation, would be plus 0.15. Another alternative would be to just simply subtract from 100% the parts that are not part of the solution. So we look at this, though, and we calculate, and this tells us that 84%, when we add up all of our percentages that we pass, 84% would fall below the score of 87. What percentage scored less than 73%? Well, we've already got our 84 right there, and we can see where this is going. 73% falls in this range right here, 73% or less. So we're talking about this piece right here. Well, it's the same way that the first deviation was going, except for we have taken away that middle deviation, which of course is 68%. So when we take away 68% from the 84% that we have, that tells us that 16% will fall in that region of scores below 73. Next thing we'll look at is what percentage of scores are more than 94? Well, 94 is in our second deviation, and then everything above. So again, if we have our little chart over there to the side, we can just add our values up. That would just be 2.35 plus 0.15, which gives us a total of 2.5%. So 2.5% would fall in scores higher than 94. And then the last one kind of leads us into this. 2.5% score less than what value? Well, 2.5% was the second deviation above. So it's going to be the same thing, the second deviation below. So 66 is laying in the same spot that 94 is. So the answer to this would be 66%. And they already told us less than. So 66% or less will be the region that gives us 2.5%. Your bell curve does not change. So if you happen to memorize these values, like the other one being up to 84%, the values above the second deviation is 2.5, you're welcome to memorize those because they will not be changing. So let's take a look at our second example here. It says, given the time required for a group of students to complete a physical fitness obstacle course, results in a normal bell curve with a mean of 21. Anytime we're given a mean, that is the center of our bell curve. So this is going to be 21. And a standard deviation of 4. So the deviation above will just be 21 plus 4, which is 25. Then plus 4 would take us to the next deviation, which is 29. And then for the last and third and last deviation, plus 4 takes us to 33. But we also have deviations below. So that would be 4 below 21, which is 17. 4 below 17, which is 13. 4 below 13, which is 9. So this is our normal bell curve. This is our distribution. Again, 34 fall between each of these regions here. Between the first and the second deviation is 13.5 on both sides, on either side. 2.35 falls in between our second and third, and then the last little bit, which is barely even visible, is 0.15% in our beyond our third deviation. So again, 2.35, 2.35, and then this one is 0.15%. All right, so let's take a look and see what we've got here. What percentage took longer than 29%? Well, this percentage is still the same as the one we had last time. 29 is our second deviation, so we're just looking values above our second deviation. Above our second deviation is always 2.5. And I got that by adding 2.35 and 0.15. Now let's take a look at the next one and think about this real quick. What percentage took less than 29 minutes? Well, if 2.5% took more than, all we need to do is subtract that value from 100%. So if this is the case, we are talking about 87.5%. 97.5%. (97.5%) fall into that range. Next one, what percentage took between 13 minutes, that would be right here, and 29 minutes, which is right here. So we're trying to find our section right there. Well, this one was very kind because it is the second standard deviation. All of this is the second standard deviation. So if you look back at your chart at the very beginning, you're going to see that that normal bell curve, that normal distribution should be 95% falling in between the second deviation. So I don't need to do any calculations on this. That is the second deviation, 13 and 29 are. So my percentage is 95%. Now the next one takes us to 13 to 25. Well, 13 to 25% is very similar, but we are going to cut off at 25. We could add up those percentages, or we can just recognize the part that we took away. Well, we were sitting at 95%, but we took away 13.5% from our 95%. So when we take 13.5% away from 95, we are now at 81.5%. Last question on these, and then you guys will be on your own with those examples. It says, what percentage took longer than 17 minutes? Well, 17 minutes is our lower first deviation. So we're going to have all values above that. We can add those as we go along. This is the entire 68. So I'm going to go ahead and just put the 68 down there so I don't have to think about it anymore. We add our 13.5%. And then the last bit is 2.5%. So essentially what we have is 68% plus 16%. And if you recall, we had this number earlier because it is a normal distribution. So if we have these ranges, it's always going to be the same. In this case, that is 84%. I'm going to leave you with the exercises. Keep those in mind. Remember, you start with your mean and you build off your deviation. So you'll be doing those two examples, and then the last thing we'll talk about is the z-score. I've got a formula for the z-score here. I'm not sure if I got that down. I'm going to try to get this down for you on your Kami link, but if I did not, go ahead and write this down. This is the formula for a z-score. What a z-score is filling in the gaps between the deviations. We know that the middle is our mean. This is our average value. We know that this is the first deviation, first standard deviation. This is the second. This is the third. This is the -1. This is the -2. This is the -3. The problem we run into is sometimes our scores don't fall perfectly on these numbers. So what a z-score is telling us what the answers are. So these are z-scores themselves. This is a z-score of 1. This is a z-score of 2, 3, -1, -2, and -3. Those are technically z-scores. And then 0, of course. But a z-score will not only tell us our values, a z-score is also going to tell us the values between. So if it doesn't land perfectly on one of these standard deviations, maybe somewhere in the middle here, we can calculate the percentage that works in there. Let's just take a look at some of these examples. First off, again, we need the data point, we need the mean, and we need the standard deviation. So let's do a little reading here. It says a small dog litter is normally distributed with a mean of 6 and a standard deviation of 1.5. So let's fill out our bell curve, right off the bat here. 6 plus 1.5 takes us to 7.5, plus 1 takes us to 9, plus 1 takes us to 10.5. Minus 1 takes us to 4.5. Minus 1.5, Minus 1.5 takes us to 3. Minus 1.5 takes us to 1.5. So there's our normal bell curve with a mean of 6 and a standard deviation of 1.5. So what we're going to do is determine what our z-score values are. So when we look at this value here, estimate the z-score for that corresponds with the litter of 4 puppies. Well, let's pay attention to where the number 4 is. Well, it's between 3.5 and 4, so this is going to fall somewhere in this range right here. It's going to fall in this range right here. So if we were to estimate this z-score, since this is z-score 0, 1, -1, excuse me, and -2, this z-score's estimation would probably be at around -1.25, because it is beyond the first deviation, but not very far beyond it. So our z-score estimation might be 1.25, and we could break that down even further and say, well, it's a 0.5 point from 4, and it's a full point away from that. That's a 2/3 ratio. But we have our z-score formula up at the top. And our z-score formula says this: all we need to calculate is the value of interest, in this case that is 4, minus the average, which is 6, divided by the standard deviation, which in this case is 1.5. So when we put this in our calculator, what we end up with is a -1.33 repeated. Now, a z-score can be negative. If it's negative, that just means it's below the average. If it's positive, it means it's more than the average. So this one would have a z-score of -1.3. Now, the next question, is this usual? Well, the way we can tell if something is usual is if it falls within the first 2 deviations. So if the number falls between -2 and +2, the z-score that is, when it falls between -2 and +2, this is a usual situation. When we get outside of the second deviation, now we're getting into unusual situations. And if we ever get past the third, we are into an unlikely situation. Estimate the z-score if the litter had 11 puppies. We're going to not only estimate, we're all going to even calculate. But here we go, 10.5. There's the first z-score, z-score 1, z-score 2, z-score 3. So 11 puppies is even further than that. So if I had to make an estimate on my z-score would probably be, moving up 0.5 point, maybe 3.25, maybe 3.33. But we can again calculate this by taking our number minus the average divided by the standard deviation. So what we end up with is 5 divided by 1.5, which is a positive 3 1/3. And this is not likely because we are not inside the second deviation. So this is very unusual. This is a very unusual situation. So if we're taking a look at this, the z-score down at the bottom, it says, what is the size of a litter that corresponds with the z-score 1.89? Well, 1.89, remember there's the z-score 0, there's the z-score 1, there's the z-score 2. Well, on our z-score 2, that was 9 puppies. So if we're taking a look at this, this is incredibly close but below our second deviation. And these are puppies, so we're not going to deal with percent or proportions of these. This is sorry, not sure what happened with there. This is going to be probably 8 puppies, because it is not a full 2 deviations. And like I said, we may end up with a percentage here. And the way we would calculate this is we would go 1.87 equals the amount we don't know minus the mean divided by 1.5. We would multiply both sides by 1.5. We can do this while we're already here. And again, we're probably going to get a fraction, but our application keeps us from having fractions. So when I multiply times 1.5, what I get is 2.835 and x minus 6, so I would add the 6 to get it to the other side. And like I said, we're going to get here 8.835, so 8.84. But again, we are not going to have 8.84 puppies, and we don't have a full 9th puppy, so this is probably going to be the number 4. Excuse me, the number 8, sorry. All right, what is the range of litter size? What range of litter size is considered unusual? Well, outside of the second deviation is what's considered unusual. And since our second deviation is 9, and our lower second deviation is 3, what's considered unusual would be values outside the range of 3 and 9. And then let's talk about how we're going to use this. If there's a sample of 40 mother dogs, how many would be between 3 and 9 puppies in the litter? Well, between 3 and 9 is 95%. If we look back at our bell curve, the normal distribution that falls in there is 95%. So what we need to do is multiply the number of outcomes. In this case, the outcome is a puppy, 40 times our percentage, which is 0.95. So 95% of our data is going to fall in there. So on these mothers, we will multiply times 0.95, and the answer I get is 38. 38 of the litters will fall between the range of 3 and 9 puppies. All right, you're going to want to go back and fill in the gaps that you had for exercise 1 and 2. Don't forget to get a copy of that z-score down. Remember, it's the number minus the mean divided by the standard deviation. Keep in mind that number can be negative. And all it is there to fill in the gaps between those perfect little deviation 1, 2, 3, and negative 1, 2, and 3. All right. Have a good day. B